If blocks are displaced slightly in opposite direction and released, they will execute SHM and we have to calculate the time period. देखो सबसे पहले we will discuss one method that is known as the restoring force method. So I will write here restoring force method. In the restoring force, suppose I say this block move distance toward this side, that is x, and this also move distance x. Then restoring force acting on this block is given by toward this side, that is F1, and on this block the restoring force will act toward this side, that is F2. And we all know the restoring force on the F1 will be, block 1 is written as the F1 equal to minus k into x, and you can say this is the direction of the restoring force. On restoring force on block 2 is given by minus kx, and this is the direction. Now, what is the net restoring force? If we calculate the net restoring force, that is F1 minus F2, and when you do F1 minus F2 and count the direction also, it will be given by minus 2kx. Now, if restoring force is minus 2kx, and we know when the restoring force was F equal to minus kx, time period was given by 2 pi root m by k, and when the restoring force is given by 2kx, time period of oscillation will be given by 2 pi root m upon 2k, because restoring force is changing from k to 2k. One more method I want to discuss here, that is known as the energy method. Listen, suppose we compress the spring and release, we know no external force along the direction of motion, only internal force is acting, and that force is the spring force, and we have discussed earlier, so the center of mass of the system will not change during the motion. And let I say this block M moves towards right by distance x, and this moves distance x left, then total compression in the spring is given by 2x. It means energy, the potential energy stored in the spring is given by half k into 2x square, because compression is 2x, and velocity of the block at this instant is v, and v we can say it is half mv square plus half mv squared, you can multiply by 2, and this is always constant. We open the bracket and solve it, we will get 2 to the 4, and this is 2, so you will say it is 2kx square plus this is 1 by 2 into 2, that is only mv square equal to constant. Now we differentiate with respect to time, we will say it is 2k, it is 2x, it is dx by dt, plus m, it is 2v, it is dv by dt equal to 0. In the next step further we will write, जो भी कैंसिल हो रहा है उसको आप यहाँ पे कैंसिल करो, तो आप लोग देखोगे dx by dt से v तो निकल गया, 2 कॉमन लेके निकाल दिया आपने, और फिर आपको क्या मिला यहाँ पे dv by dt प्लस 2kx upon m equal to 0, and dv by, it is dv by dt, not dt square, dv by dt. So you can say acceleration a equal to minus 2k by m into x, and again we compare with a equal to minus omega square x, omega की वैल्यू आ गई root 2k by m, and time period of oscillation is given by 2 pi by omega, so 2 pi by omega की जगह लिखोगे तो ये क्या आ जाएगा m upon 2k. So that is the answer from the energy method. And last method which we take, that is the quite simple method, and I say that is the reduced mass concept which I have discussed in the last class. So we take the reduced mass concept. We know if two blocks of mass m and m or m1 m2 are placed, then reduced mass mu is given by m1 m2 upon m1 plus m2. Here both the objects are of same mass, so mu is given by m by 2. Now we use the formula T equal to 2 pi root mu upon K equivalent. So we will say T is given by 2 pi root m upon 2K. So this is the answer of this problem.